Kia ora Year 12. Today what I thought we'd do is have a look at what we can do so far in the 2018 Level 2 Algebra paper. So I think for some of you this will be a boost to your confidence if you've been keeping up with the work, and for others it's going to make you realise that you really do need to make the skills that we're learning every day automatic. So I'm going to start by quickly showing you just the questions that we're going to do from the 2018 paper. So first of all, from question 1 we've got these 3 questions, and then from question 2 we've got these 3 questions, and then from question 3 we've got these 3 questions, and I'm going to give you those out in class along with the formulae that you'll get on the formula sheet. So what I'm going to do now is just go through all of the questions. Hopefully it won't take 15 minutes, but if it does I'll go on to a second video. So before you watch this, I really need you to have done these questions as best you can on your own. So if you're watching this tonight, just shut the video down now and we'll do it all together in class tomorrow. Okay, so let's have a look at question 1. You can see that we've got a couple of simplify fully questions. One's got a fractional power in it. This one here, oh, don't know what's happening there. Here we are. Right, so that's got a fractional power. This one here's got a negative power. And in question C, you can see that we've got an algebraic fraction thing, which is what we've been looking at this week. Okay, so working through them, we have to simplify 25m to the power of 16 all to the power of 1/2. So we take our 25 and we go 25 to the power of 1/2 times m to the power of, and I'm going to multiply the brackets together, so it's 25 times m to the power of 8. Now some of you will have gone straight to going the square root of 25 is 5, and you'll go straight to your answer here, which is 5m to the power of 8. Okay, so give yourself a U code and achieved code if you got that one. On to the next question. Simplify fully this thing here, leaving your answer with a positive index. So let's see, we've got 4 over 3a to the power of -2, which is equal to 3a divided by 4 to the power of +2. Expanding all of that out, we get 9a squared divided by 16. So give yourself another U code if you've got that. Right, now let's look at this last question. We've got an algebraic fraction, and we have to write it as a single fraction in its simplest form. We'll just clean that up a bit. Now, I know some of you don't like these very much yet, but the best way to think about that 4 is think about it as 4 over 1. So now it's a fraction, minus b plus 8c over 3c. Remember that when you've got this fraction line, this works like an invisible bracket, but it's so easy to muck these up when you've got a subtraction. So put your brackets in here and make them into visible brackets. Okay, what can we do next? Well, we're going to get a common denominator, just as we always do, and the common denominator here is going to be 3c. Now, I'm going to do this really slowly, so I'm going to do it as 2 separate fractions. Right, what did we do to the 1 to get to a common denominator of 3c? We timesed it by 3c. So that's what we have to do to the 4. 4 times 3c gives me 12c. What did I have to do to 3c to get to 3c? Nothing at all. We're timesing it by 1. So we're going to have 12c minus, in brackets, b plus 8c. Let's clean that up now, and we're going to have to collect up some like terms. We've got 12c minus b minus 8c. So my final answer here should be 4c minus b over 3c. Right, if you got all the way down to there, give yourself a merit tick. So that's an R. On to question 2. Right, 3 questions. This time we've got a couple that have got logs in them. So find x if blah, 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 that's got a log, and find m if log of blah, blah, blah is this. And the last one we've got is one that we've kind of done but not properly yet. There are some great pages on these in the Walker book, and I'm going to come back to these early in term 2, but I thought we could give that one a go now as well. Okay, so as long as you remember the loopy thing, the first one is pretty straightforward. So we can rewrite that log equation like this. X to the power of 5 is equal to 243. 2 ways to do this. The first way is by remembering our common powers of 2's and 3's. So we know that it's not going to be a power of 2 because it's not an even number. So powers of 3, 3 squared is 9, then we get 27, 81, and 243. So x is equal to 3, and that's fine. Okay, so that's a U code. But if you didn't spot that straight away, how can we undo something being to the power of 5? Well, if we take both sides and we place them to the same power, that's going to work as well. So if we take the fifth root of x to the power of 5, we get back to x. And then on our calculator, we can say 243 to the power of 0.2, and we'll get x equals 3. So that's, not surprisingly, because it's about as simple a log question as you can get, this is a U code. Right, what was the second question? Well, the second one's very similar. We have to find m if this equation is true. So it's another loopy thing. We're going to have, so let's write it out to start with, log to base 3 of 4m minus 1 is equal to 2. Okay, 3 to the power of 2 equals this. 3 squared is equal to 4m minus 1. 9 is equal to 4m minus 1. 10 is equal to 4m. Dividing both sides through by 4 gives me 10 over 4 equals m. But I've got to simplify that. So it's m is equal to 5 over 2. Or you could say m is equal to 2.5. Right, give yourself a U code for that one as well. Now let's look at this last one. We've got things with 3s and 9s and 27s. And we have to find an expression for x in terms of w. Right, I just need a little bit of working space for this one because this is a little bit more involved and this is a merit question. So let's start by writing it out and seeing what we could do first. And looking at what we're being asked to do. Well, we have to figure out some expression for x. So we're going to have x equals blah, 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 and it's going to have some w's in it. We've got a 3 here, we've got a 9 here, and we've got a 27 here. We're going to replace those all and get a common base. Okay, so we're going to do nothing to that 3. We're going to have 3 to the power of 4x plus 1. But instead of 9, we're going to have 3 squared. And instead of 27, we're going to have 3 cubed to the power of w over 3. Cleaning that all up gives us this. 3 to the power of 4x plus 1 over 3 to the power of 2x is equal to 3 to the power of, multiplying those together, we get w. Now we go back to year 9 and we remember that when we've got the same base, we just subtract the powers. So we've got 3 to the 4x plus 1 minus 2x is equal to 3 to the w. So that simplifies to 3 to the power of 2x plus 1 is equal to 3 to the power of w. So if these bases are the same and the whole thing is the same, that means that 2x plus 1 must equal w, and we had to get an expression for x. So 2x is equal to w minus 1, x is equal to w minus 1 over 2. And that's a merit mark for that one there. Okay, so quite a lot of steps in there, but actually once you spot that you just have to change the base, the steps after that are, I think, reasonably obvious with what you need to do. Third question, we've got 3 equations. So the first one is to solve this. So that looks like a pretty easy quadratic. This one looks weird. We'll come back to that. And then this last one is what we did today. Show that the graph of the function, this, does not cross the x-axis. As soon as you see that, you should be thinking about showing that the discriminant is negative. And we must use algebra to support your explanation. In other words, you can't just go to your graphics calculator, draw it, and copy the picture. So let's go back to A. Solve each of the following for x. Well, we've got 12x squared minus 5x equals 2. As you know, to solve a quadratic, the best way to go is to get everything onto one side and have it equaling 0. Now, if we look at this one, we're going to look at it and see we can't factorize it that easily, but we can if we do grouping. So something times something equals negative 24. Right, so that's those two. And then something plus something equals negative 5. Two numbers that times together to give me negative 24 and have got a gap of 5. So it's got to be something to do with 8 and 3. And we'll make the big one, the negative 8, is going to be the negative one. So let's see if that works. Yep, that looks good. So now we're going to split this middle term up using that method. We have 12x squared minus 8x plus 3x minus 2 equals 0. Factorising in steps gives me this. 4x into 3x minus 2 plus, no common factor in here, so it's going to be 1 into 3x minus 2 equals 0. So my common factor here is 3x minus 2 into 4x plus 1 equals 0. X is equal to 2/3, or x is equal to negative 1/4. Now I know everyone's going to have something to say when I tell you that you can just do that on your graphics calculator, right? You can't do it in that form, but as soon as you've got it into this form, you can substitute that in and solve the quadratic. Okay, so we can talk about that more in class. It's really important, though, that you do know this grouping method for doing other problems. But in this case, you can get all the way through to here by using your calculator. Not recommended. Okay, this next one looks really weird, but it turns out to be a quadratic. And the way that we see that is if we're confident working with algebraic fractions. So let's turn these into fractions and then ask what to do next. Well, we have to get a common denominator. The common denominator here is going to be x. Right, 1 times what gets me to x? 1 times x. So I have to do the same thing to my numerator. We get x squared, same thing on the next term. I times the 1 by x, I have to do the same to the 1. So x squared plus x minus 3 is equal to 0. That gives me x squared plus x minus 3 is equal to 0, because I'm going to multiply both sides through. So times both sides through by x. 0x is equal to 0. So that's why that's going to work. Now you can do the quadratic formula on this. You can't factorise it and you can't do grouping on it. If we do or you can put that into your calculator. If you put it in your calculator, you'll get out the two answers. But I'm going to use it for some quadratic formula practice. X equals -1 plus or minus the square root of 1 times 4 times 1 times -3 divided by 2. That gives me -1 plus or minus the square root of 13 divided by 2. Leading to two answers, x equals 1.303 or -2.303. And that's U code, right? I think that's quite a mean U code, but that's how it was. Okay, so I can't do anything about it. So a little achieved question at the tricky end because you had to spot that it was a quadratic to start with. Okay, then the last question in here I think is a really easy merit question, and it's this one that we looked at today, all about the discriminant. So I've just got time to talk about this. It's really important if you want to get the full marks on this question that you explain your reasoning. Okay, so show that the graph of the function doesn't cross the x-axis. So I've got some kind of function like this. Right, we've got y equals 2x squared minus 5x plus 6. Right, and we're going to set that equal to 0 to find the x-intercepts. So this is what I think I would write out first. B squared minus 4ac is equal to what? Well, a is equal to 2, b is equal to -5, and c is equal to 6. So b squared minus 4ac is -5 squared minus 4 times 2 times 6. That gives me 25 minus 48, which is equal to -23. But I'm not done if I just go that far, because I have to then explain what that means. But you don't have to take many words to do that. I'm talking fast because I'm running out of time. What you need to say is that that is less than 0, therefore, or so, there are no real roots. Graph does not cross the x-axis. So there you go. That's all for now. We'll do another one tomorrow. Thanks for watching.